You gave up. No, I'm back. You want to tell him something? How are you, sir? University was the brilliant student in the world. And religion. Out the one. He's the most brilliant student in the world, not just in Oman. But he gave up for it. No. He did. So thank you so much.
Hello, and give my best wishes to your student. Okay, I'm now, let's say, live on YouTube and Facebook and let's say Instagram. Okay, I'm explaining how can you solve polynomial to the power 8. Okay, I hope so that you will reach, let's say, or I hope so that your student has to think deeply. Okay, in numerical subject fields. Okay, encourage him. Yeah, he seems like to be really, as you told, that he's the wonderful or extraordinary learner. Okay, so give my best wishes. Thank you. So, learners, how are you doing? It's Murad, Sultan, Ezouidi, the pioneers in methods. Okay, is now ready for you. I Yesterday I gave you an example. I gave you, let's say, uh, uh, an eighth degree from the equation, and I told you please try to start finding out the roots of these eighth degree from the equation, and knowing that all the roots are real numbers, not complex numbers. Okay, so now it's time. I'm going to share, let's say, my work. Okay, for you to get the point and to understand how can you solve this kind of polynomial equation. But before that, I'm going first to share the link for my colleagues so that they can be benefited from my research in mathematics. Okay, I will try to share first the, yes, solve the eighth degree polynomial equation. This is our polynomial equation. I'm going to share it first. Okay, okay. I'm going just write eighth degree from the equation. Okay, so learners, here it's the pioneers in methods. Murad, Sultan, Ezouidi, HSM. H means the name of my mother, S the name of my father, and M is gonna be Murad. Okay, so today, as we told that, we try to solve these polynomial to the power 8. Okay, and we will, let's say, prove that the roots are real numbers. Okay, are real numbers. Okay, so these are this is our polynomial equation, learners. Okay, this is done. I'll just erase this. This is example number 3 done. Okay, now this is the question, learners. I already, let's say, told you that we are going to, or is I already make notification here. Okay, this is the notification that I did. This one. Okay, this one is gonna be another call. You see, this is another call. Okay, so this is me, Murad Sultan Ezouidi, the pioneers in methods, the researcher, the Tunisian researcher, and this is my brother, eldest brother, let's say, senior teacher of English, and this is my youngest brother, Tarek Sultan Ezouidi. Okay, and these is called polynomial to the power 8. So P of x equal x raised to the power 8 minus 16 x raised to the power 7 plus 7,132 divided by the square of 8 x raised to the power 6 minus 225,920 divided by 8 cubed x raised to the power 5 plus learners 4,449,726 divided by 8 raised to the power 4 x raised to the power 4, yes, minus 55,799,680 divided by 8 raised to the power 5 x raised to the power 3. Okay, plus learners, just a minute, I'm going to share this for my bar. Okay, tell him. Okay, hello Brad Tarek, now I'm live, Brad Tarek, to explain this polynomial to the power 8. Okay, So you can join the lecture, and thank you for replying me. Okay, thank you. Okay, so learners, we told that in fact plus what plus okay 435 million 55,468 divided by 8 raised to the power 6 the square of x minus learners 1,928 million 228,224 divided by 8 raised to the power 7 times x plus learners okay 3,719 meaning of course 657,865 divided by 8 to the power 8 equals zero. This is our polynomial to the power 8 that we are going to solve together. Okay, you are here learner and colleagues and professors to learn from you how can you use the discriminant formula of Murad Sultan Ezouidi. Okay, we continue with all these learners. It's called, in fact, eighth degree polynomial equation, simply because the highest power is going to be 8. Okay, now I will proceed. I will proceed now, learners. I will use the discriminant formula of Murad Sultan Ezouidi. This is use the discriminant formula, discriminant, discriminant formula of me to find s minus 1 and S0 and S1 and S2 and S3 and S4 and S5 and S6 and S7. Okay, this S subscript K minus 1 of the R is called the coefficient of the new eighth degree polynomial equation that is related to the original eighth degree polynomial equation. After finishing step A, you are going to move to the second step, okay, to continue finding the roots because you can't solve this polynomial to the power 8 if you are not able to find, let's say, the new 8 degree polynomial equation. Okay, and don't, let's say, use factor theorem or uh, remainder theorem. Okay, because you don't know, you will never, let's say, make a chance randomly, we choose randomly, for example, x equal 10, okay, and you are going to replace in the eighth degree polynomial equation x equal 10 to check if it is 0, so 10 is a root, and also you can tell x minus 10 is a root, and if it is not, let's say, equal to 0, means that it's not a factor. So this is, it's called bad method. Okay, we'll never find you the real roots of this polynomial to the power 8 that I'm going now to solve. I gave this example yesterday, and I told you at 8 o'clock I will be on live for you to explain this. Okay, so learners, I'm now proceed. I should continue. Now learners, I'm going to use my discriminant formula, this one, to find s minus 1. By convention, s minus 1 is going to be equal to combination and choose minus 1 plus 1, which is equal to combination and choose 0, which is equal is 1. Okay, but for k equals 0, meaning that you are going to substitute k equals 0 in the discriminant formula of Murad Sultan Ezouidi, you'll find that S0 for the R is equal to 0, simply because the sum of the roots, the x roots of this new 8th degree polynomial equation is going to be 0, okay? Then, after calculating this, learning that substitution, this is L0 for the Q is going to be 16, and combination and choose 1 is going to be 8 choose 1. So minus 8 choose 1 times 16 plus 8 times 16. So it's going to be equal to now. Okay. Now I should continue, learners. We want to find the S1. To find S1, learners, go to the discriminant formula of me and substitute K equal to. Okay. This one, learners, this one, I mean, is the general formula for any nth degree polynomial equation. This one that I'm going to show you now, this one, yes. This one, learners, this, okay, is gonna be the discriminant formula of Mr. Murad Sultan Ezouidi. I will try to make like that. Okay, okay, these, it's called discriminant formula of Mr. Murad Sultan Ezouidi. When putting k equal 0, minus 1, 0, and minus 0, 0, and 1, and 2, and 3, up to 8 minus 1 minus 7, you will get the new coefficient of the new eighth degree from the equation. Okay? So by calculation, after calculating and developing and expanding this formula, when k equals 0 and 1 and 2 and 3 and 4, we obtain that S1 of order R, this is the formula of me, okay, equal negative 36. So we are going to focus on this negative number, okay, because the value of the third coefficient is going to be negative 36. So we need to find the fourth coefficient and the fifth coefficient and the sixth coefficient and the seventh coefficient to find to this method will lead you to a new eighth degree from the equation where you should find out all the x roots. Okay, so I will use my discriminant formula, which is sk s subscript k minus 1 over I equals the sum from 0 to k combination n minus r choose k minus r n raised to the power r between parentheses negative and 0 for the q raised to the power k minus r times lr minus 1 over the q. This one, learners, has to be equal when putting k equal 2, you mean that you will get S2. After developing this and simplifying S2, I will just concentrate or look at the last generalized formula, which is combination 2 choose 1, which is equal to 2 times combination n choose 3 times 0 for the 2 raised to the power 3 minus combination n minus 2 choose 1 n squared times 0 for the 2 raised to the power 1 times n1 of all the cube plus n cubed raised to the power 3 times n2 of all the cube. I will now calculate this, learners. Okay. After calculating this, you can use a calculator, learners. I will give you 1 minute if you want, okay, to calculate this. And at the same time, I'm going also to make calculation for you for those who are not able to calculate this. Okay. So this is S2. I will put it like that. Sorry. Sorry. Okay, like that. We have combination 2 choose 1 times combination 8 choose 3. So 2 times, this is 8 choose 1, 8 choose 2, 8 choose 3, which is 56. So I will make 2 times 56 times what? Times 16 cubed times 16 raised to the power 3. Good man. Okay. Then minus 6 choose 1 is 6 times 16 times 7,132. Why? Because 8 squared divided by ratio of 1. So it's going to be 1. Okay. I'll just write immediately, automatically, I will write 6 multiply by 16. Sorry. Multiply by 16. Okay. Multiply by 7,100 plus 8 cubed divided by 8 cubed, it will be cancelled out. I'll just write plus 220,000, 225,920 plus, okay, 225,920. So this one, learners, has to be equal to, and now you see, this is 0, okay, and here is gonna be equal to 0. Therefore, sorry, therefore, S2 is equal to 0. Now I'm looking for S3. To find S3, learners, you have to substitute K in the discriminant formula of Murad, Sultan, Ezouidi. Okay, and this discriminant formula had been, let's say, generalized after 14 years of work. Okay, night and day. Okay, and thanks to God that we obtain and we get this secret, okay, this given formula of nth degree from the equation. And these also works for nth degree linear equation, okay. Now, after putting k equal 4, I should obtain S3. You see, S3 simply because 4 minus 1 will give you 3. And all of this is expanding this formula. We are going to make the expansion. Okay, you can note that L0 for the q raised to the power 4 is common factor. I should put it here. Then combination n choose 4 minus n combination n minus 1 choose 3 is going to be equal to negative 3 combination choose 1 times combination n choose 4, and the rest coefficient or terms has have been written as they are, not changed. Okay, because in the first, when putting r equal 0 and r equal 1, we will obtain something in common, which is a 0 for the q raised to the power 4, and here a 0 for the q raised to the power 3 times a 0 for the q of all the a 0 for the q. So this one has to be raised to the power 4. That's why it's called common factor. Now I'm going to focus on the last answer, and I should calculate this, and you should find that S3 is going to be equal to 446. Okay, 46. I will give you time, learners, to think of these and solve it. Okay, team. I'm going to rationalize the answer. Okay. Okay, this I'm going to make another call means learners. I make publication like that, publication like that. Okay, it's called another call. Pioneers in methods. Okay, in Arabic. Okay, pioneer رائد رواد الرياضيات. Okay, رواد الرياضيات. It will be solved a degree from the equation means حل متعدد الحدود من الدرجة الثامنة، مش الثانية أو الأولى أو الثالثة. Means you are going to solve polynomial where the highest power is gonna be more or equal than 8. Okay, and for this kind of example, I will try to rename my channel by telling it will be like another call. Okay, another call. Okay, means the another call is a plan for the future, not for me, but for you, learners, students, colleagues, professors, okay, universities, the whole world, the universe. Okay, because this is a fact. We reach to solve whatsoever the highest power of any polynomial to the power n. Of course, regarding and working through the discriminant formula of me, of Mr. Murad Sultan Ezouidi. After 14 years of work, we get to breathe in. We get to continue breathing in. Okay, simply because we, from the beginning, when I was a child, I really love mathematics. Okay, and I was looking for developing or evolving, let's say, my skills in mathematics. But our, let's say, uh, our ways for teaching, okay, it depends on explaining, and you should write your courses, okay. But there are some strategies, yes, there were so many strategies in mathematics, but we as Tunisian people, as Tunisian, let's say, children, we use it to evolve ourselves by ourselves. Okay, and for this reason, this is another call for those who want to continue breathing in mathematical fields. Okay, so we continue learning. We told that. Okay, we told them I'm going to calculate this. So this is my own calculator. I will put this is going to be equal to 0, and we will prove that the roots really are real roots. After finishing solving this example, learners, go wherever you want to go. Even if you would like to ask AI, artificial intelligence, he will tell you that this domain, this kind of questions, in fact, we can solve. May we use approximation method? okay, of Newton, okay, and these will never give you exact roots. But Mr. Murad Sultan Ezouidi is here with you to learn, to let you learn from new, okay, and to get rid of the new, let's say the usual pathways or methods that you use, like factorization, like checking is plus -1, plus -2, plus -3, plus negative n is a root. Okay. And also, Mr. Murad Sultan Ezouidi will lead you not to use the estimation error, because there is an estimation error if you are going to use method of Newton. Okay. So here you are involved to calculate S3. So S3 learn is going to be -3, okay, times what? Times 8 choose 4. This is 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4 means 70, times 70. Times 16 raised to the power 4, times 16 raised to the power 4, okay, plus 6 choose 2, 6 choose 2 means 15, plus 6 choose 2 is 15, times 8 square divided by 8 square, no need to write it. It's a ratio of 1. Like 4 divided by 4 is 1. Okay? Like exponential raised to the power 0 is 1. So times the square of 16 times the square of 16 times what? 7,132 times 7,132 minus combination 5 choose 1 minus 5 minus 5 times 16 raised to the power 1 times 16, okay, times what, learners? Times, you see, 8 cubed divided by 8 cubed is a ratio of 1, times 225 times 225, 920 plus 8 raised to the power 4 divided by 8 raised to the power 4 is a ratio of 1. So I'll just write plus 4,449,726 plus 4,449,726. Then I'm going to make equal sign, and I will see if S3 is equal to 0 or equal this value. Okay, this one has to be equal to 446. Means the C there for, okay, 1, 2, 3, 4. This is the fifth coefficient. Okay, because the first coefficient of my eighth new degree from equation is gonna by convention is 1, simply because n to 0 is 1. Okay. Now we told that is 446. I mean is 446. Okay. Okay. I like that. Okay. So this one. So now, learners, I'm going to find S4 means you should sorry, put k equal 5 in the decimal formula of me this one. S subscript k minus 1 over r equal the sum from 0 to k, combination n minus r choose k minus r, n raised to the power r, between parentheses, integral 0 of all the q, k raised to the power k minus r, choose 5 times l k minus r minus 1 of all the q. Okay. This one, after developing this and simplifying, if there is, of course, some common factors, okay. If not, we are going to write the terms of these as for when you are making the expansion. Okay. Now I will just write this as 4 is equal, this is a general formula, general discriminant formula, when k equal 5, using my discriminant formula, find the fifth, the sixth coefficient of your new eighth degree polynomial equation. So is written as combination 4 choose 1 times combination n choose 5 times L0 for the q raised to the power 5 minus combination n minus 3 n squared times L0 for the q raised to the power 3 times L1 for the q, of course, plus combination n minus 3 choose 2 and cubed and 0 42 raised to the power 2 times n2 42 minus combination n minus 4 choose 1 times n raised to the power 4 times n0 42 raised to the power 1 times l3 42 plus n raised to the power 5 times l4 of 42. Now it's a simple method for you to continue. uh, I will make this is down because I need this. I need the coefficient. Okay, because I need the coefficient of my original 8th degree from the equation. Okay, so learners, I'm going to calculate this. Okay, I will give you time to think of this and calculating if it is possible. Okay, I will go back if it is possible like that. Go back like that. Okay, I will use my scientific calculator and I'm going to calculate it. So at the same time, learners, you will try to calculate with me, okay? And you will find your coefficient, okay? Using, of course, my discrete formula when k equal 5, because uh, s k minus 1, k is 5, it will be s4 minus 1 of order r. So I will write this as near 4, choose 1 is 4, I will write only 4, times what? Combination 8 to choose 5. So this is 1, 2, 3, 4, 5, 56 times 56 times 16 raised to the power 5 times 16 raised to the power 5. Okay. Minus learn is what? Minus 6 choose 3. This is 6 choose 1, 6 choose 2, 6 choose 3 means negative 20 or negative 20 times 8 squared divided by 8 squared is 1 times 16 times 16 raised to the power 3 means cube, okay, times 7,132 plus combination 5 choose 2. This is 5 choose 1, 5 choose 2, which is 10. So just write plus 10 times what learners times 8 cubed divided by 8 cubed is a ratio of 1 times 16 squared, 16 raised to the power 2, okay, times 200, 225, 920, because this is the coefficient, you see, L2, because this is the value of L2, minus 4, simply because 4 choose 1 is minus 4, times 8 raised to the power 4 divided by 8 raised to the power 4 is 1, times 16, times 16, times 4 million, times 4 million, which is L3, 4 million, okay, okay, times we told, times is Murad make times we told, okay, I will just check again, minus uh, minus 4 times 16, yes, الحين times very good, times 16 times 4 million 400 and 4 million 449,000 726 726 indication. Okay, I'll just write this one as 4,449,726. 4 million, 4, okay. Then the plus 8 raised to the power 5 divided by 8 raised to the power 5 times this one. I'll just write plus. Okay, it will be 55799,680. Okay, the last word is this one because L4 is this. Okay, this one has to be equal, learners, equal a now. So S4 is equal to 0. Clear? If you are going to make a recap, S0 is 0, S2 is 0, S4 is 0. Okay? Now, but S1, S minus 1 is different to 0, S1 is different to 0, S3 also is different to 0. Okay? So, because it has be, we calculate it will be 446, I thought, something like that. I will go back to check. Yes, 4 as 3 is different to 0. It will be 4, 4, 6. Okay. So I will continue, learners, and I will show you the rules of this polynomial to the power 8 are all them real. Okay. Means if you will use the decimal formula of me, you will get the exact root. Okay. And this formula had been generalized for any n-degree formula equation. Okay. Even if we would like to go uh, to dive deeply in these fields, you will be needed to use this discriminant formula of me to work out all the exact roots. Okay. Now I'm looking for finding S5 learners. Just put K equals 6 in the discriminant formula of Murad Sultan Ezouidi, the Tunisian researcher in the field of mathematics. Okay, mathematics or mathematics. I prefer I prefer pronounce it as mathematics. Mathematics. We say mathematics. Good man. Mathematics again. Mathematics or mathematics. In fact, both of them are correct. But I prefer pronouncing it as mathematics, not mathematics, and not mathematics. Okay. Although that I studied everything in French, but I was good at English. Okay, because the Tunisian teacher, the Tunisian English teacher, are very, 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 very extraordinary. We as Tunisian, we got correct pronunciation, correct, like we are native speakers. So we continue. We told that this is as 5 equal the sum from 0 to 6. Combination n minus r choose 6 minus r and raised to the power r between parentheses negative 0 for the q raised to the power 6 minus r times L1 of all the Mr. Murad for the yeah 6 minus r times Lr minus 1 for the q. After calculating this and making the expansion, or after expanding this, we will note you as a learner that there is something in common factor we put outside parentheses. Then you will make the difference between n to 6 and minus n choose n minus 1 to 5, which is equal to negative 5 choose 1 times combination n choose 6. The rest terms are written as they are. Okay. Now we focus on the last one. This one, you see, the last one, S5, for the I equal combination negative, of course. 5 choose 1, A choose 6, and 0 for the q raised to the power 6, plus 6 choose 4, n squared, and 0 for the q raised to the power 4 times n 1 for the q minus combination 5 choose 3 and the cubed times n 0 for the q raised to the power 3 times n 2 for the q plus combination 4 choose 2 and raised to the power 4 times L0 for the q raised to the power 2 times L3 for the q minus combination 3 choose 1 and raised to the power 5 times L0 for the q raised to the power 1 learners times L4 for the q. Okay, plus n raised to the power 6 times L5. So this one, learners, I will just make substitution in this discriminant formula of Mr. Murad Sultan Zwidi, the owner of this formula, and we'll calculate. I will get that is equal to negative what negative 2196. Let's check, learners. You have your own scientific calculator. Okay, prepare yourself, learners, and me also. I'm going to use this one. Okay, and I'm going to make challenge to define the AI, artificial intelligence, to change this fact. Okay, so here what we have learned, oh my god, it's 5. I will write it as negative 5, negative 5, Mr. Moore. Times 8 choose 6. 8 choose 1, 2, 3, 4, 5, 6 means 28. Times 28 or 28. 28. Okay. Times 16 raised to the power 6. Times 16 raised to the power raised to the power 6. Good man. Plus, okay, 6 choose 4, 6 choose 1, 2, 3, 4, means 15. This is a plus 15. Okay, plus 15. This kind of example give any, if you want, let's say, to give to you professor in the university, he can do this. Okay, he will, he will, let's say, spend more than 1 year working with this kind of examples. And after 1 year, he will tell you, my student, sorry, I can't solve this, but can you tell me who is the writer of these kind of questions? Just I'm going to tell him, hi, how are you? I spent more than 1 year working with these kind of examples, and in fact, I did nothing. Can you help me? Of course, I will tell him, I'm here, okay, to help you. Because here in this kind of mathematical fields, we use our our, how to say it in English? I forgot the word. My God. Okay, here in this kind of subject or in this kind of mathematical uh, field, we as Murad Sultan Ezouidi, we weren't able even to sleep. Okay, even to sleep until we solve this, until we derive a formula, general formula that can work with any nth degree polynomial equation. And we did this. Okay, and now these examples are very important, not for me, for you to apply the discrete formula of Mr. Murad Sultan Ezouidi. This is step A. There is another step, learners. Okay, you can calculate the new coefficient, and you should go to step B. Okay, or level B. Sorry, level B. Sorry. Okay, by time you will get to know about these secrets of diving deeply in dark waves, dark and windy, darkly, darkly. You can't say darkly? No. Okay, adverb or windy. Okay, dark and windy uh, waves. Okay, and these waves depends on this kind of discriminant formula. Okay, so we continue. We told that -5 times 28 times 16 raised to the power 6 plus 15 times 8 squared divided by 8 squared times 16 raised to the power 4 ik times 16 raised to the power 4 ik times 7,132 times 7,132 7,132 minus 5 to 3. This is 1, 2, 3 means 10. Minus 10. Times 8 cubed divided by 8 cubed. Ignore this one, okay? Because it's a 1, it's a ratio of 1. I will just write my times 16 a cubed raised to the power 3. Good man. Times what? Times L2. L2 is 225,920 times learners. Okay, 225,920 plus 4 choose 2. This is 1 and 2 means 6. Okay, plus 6 plus 6. Good man. Times 18 raised to the power 4 by 18 raised to the power 4 is 1 times 16 square times the square of 16 times the square of 16 times learners 4,449,726. Then minus a 3 combination 3 choose 1 minus 3 times 8 raised to the power 5 divided by 8 raised to the power 5 is a ratio of 1 times 16 times Mr. Murad, please, times 1 6 1 6 16 16. We can say 16. 16 or 16. Okay. So, or we cannot say 14 or 14. 16. 16. So this is 60. Let's be clear. We should clarify this kind of pronunciation. It's going to be 60. 60. 60. Or 60. Okay, whatsoever. Time is 55 million. Oh my God, 55 million, Mr. Murad. 55 million. Ma 799. 799,680. 680. Okay. Plus what learns 8 raised to the power 6 divided by 8 raised to the power 6 is going to be 1. I will just write plus coefficient plus 4, 4 million, yeah, 400 plus 435,000. This one, 435,000, 435,000, 435 million and 55,486. I'll check this one. 435 million, correct, and 55,000 and 486, not 68, 86. This is 86. This one is, sorry, 86 or 68. Okay, 86. Okay. So this one is going to be equal to, yes. So I'm going to, this one learners is, because this is 68. So I will just change this one because the coefficient of this is 468. And this one is written, oh yes, 4, I will write here. Yes, 4, where is 468? I will go down to possible. Where I am, here. Okay, yes, here we see this one. Okay, 435, 435. So this one will be, okay, after 4 is going to be 6 and 8. 6, 8. Okay, خلاص. Okay. So 468, this is 468. 5, correct. And hang out to back to calculator. So I will now cancel this. I will make minus. Okay. I should repeat. Shit. Okay. I should repeat from the beginning. Okay. No problem. Okay. I will do that. Okay. Simply because learners, I'll tell you why I will spend this would like to zoom this. Okay. You see, 435. This is 435 5055 468, and this is the coefficient 435 Okay. I will use the scientific calculator. I will start from the beginning. We told negative 5 times, or we can go back to history. Okay, history. History. We don't have history, huh? Shit. Okay, no problem. I should calculate again. Okay, so negative 5 times 8 to 6. So it will be times 80, 28 times 16 raised to the power 6. 16 raised to the power 6 plus 6 choose 4. 1, 2, 3, 4 plus 15 plus 15 times learners 16 raised to the power 16 times 115 times 10. Okay, again we have negative 5 times, we told times is mouse. What is times? Mouse works. Okay, times, okay, 8 choose 6 is 28 times 28 times 16 raised to the power 6 raised to the power 6 plus 6 choose 4 on a 1, 2, 3, 4 plus 15 plus 15 times 16 raised to the power 4 to the power 4 times 7,132. Then minus 5 choose 3. This is 1, 2, 3. Minus 10. Minus 10 times what, learners? Times 16 cubic. Times 16. Okay, times. Okay, where is times? Times 16 a cubic raised to the power 2. Then times 200, 225,920 plus 4 to 6. This is 1. This is 1, 2. So it will be 6 plus 6 plus 6 times 16 squared times 16 squared, the square of 16 times 4,449,726. Clear. Minus a 3. Where is minus? Minus 3 times learners times 16 only times 55 times 55 799 680 680. Okay, check again. So we have 55,799,680. Then plus what? Plus the last answer 435 million 055,468. Okay. Why this one? Because this is the coefficient. This one has to be equal to negative 2,196. Therefore, learners, we continue. We'll obtain the last one, not the last one, S7, yes, the before the last coefficient. I'm going to put k equals 7 in this formula of me. I'm going to focus on S6. Equal combination choose 6 choose 1, 8 choose 7, 0 for the 2 raised to the power 7 minus combination 6 choose 5 and squared, 0 for the 2 raised to the power 5 times 1 for the 2 plus combination and 5 choose 4 because n minus 3, n is 8, 8 minus 3 is 5, n cubed, 0 for the 2 raised to the power 4 times 2 for the 2 minus combination for 2, 3, and raised to the power 4 times 0 for the 2 raised to the power 3 times and 3 for the 2 plus 3 choose 2 and raised to the power 5 times 0 for the 2 raised to the power 1 times and 4 for the 2 minus combination 2 choose 1 and raised to the power 6 times 0 for the 2 raised to the power 1 times and 4 raised for the cube plus L7 and raised to the power 7 times L6. Now, I will use my calculator. Of course, this S6, this S6, this the S6, let's say uh, the discriminant formula 1k equals 7, it had been generalized for any integer polynomial equation. Okay, so I'm going to calculate this, learners. So I should make this down because I need the coefficient of my original 8th degree polynomial equation, like that. Okay, I will calculate this one, S6. So after calculating this, you will get the value of this is going to be equal to 0. I will just write 6 choose 1 is 6 times 8 because 8 choose 7 times 16 raised to the power come to the power 7 minus 6 because 6 choose 5 is 6 times 16 raised to the power 5 times 7,000 times 7,132 plus learners 5 choose 4 is 5 times 16 raised to times 16 raised to the power 4, okay, times 200 225,920, okay, minus 4 because 4 choose 3 is 4 minus 4 choose 16 cubic 16 raised to the power 3, okay, times 4 million times Okay, here negative 4 times 16 cubed, 4 million, yes, times negative 4 times 16 cubed times now, Mr. Murad, make times, use the mouse, my times 4,449,726 plus plus teacher 2 is plus 3 times 16 squared times 16 squared means 256 times what, learners? Times, okay, 5 the last one, times 5 okay, 799 means 55,799,000, yes, 680. Okay, this coefficient. Then minus 2 times 16 only times what, learners? Times, okay, 435 million, 400 455 million, okay, 055,468, 468, 468, okay, 468 plus 8 raised to the power 7 divided by 8 raised to the power 7 is a ratio of 1, and you write it, plus 19 to 8 means 1,928 million, 1,928 million, 228,224. This one, learners, has to be equal to, let's check, is going to be equal to 0. Okay, this is the Tunisian researcher, Mr. Murad, for his video, the owner of this kind of formula. It's not the only one formula, learners, it's a booklet after theorem, okay. Inshallah, one day will be spread out in the world and everyone can use it. Okay, we are here not to hide. Okay, we are to let you get learn new methods and new theories and new facts. Okay, now the last part, learning, is to find the last coefficient. I'm going to put k equal 8 in this formula of me. It will be s8 minus 1, so it is 7 to s7 of order r. I will now use the last one as 7 of order r equal negative combination 7 choose 1 L0 for 2 raised to the power 8 times plus n squared L0 for the 2 raised to the power 6 times L1 minus n cubed L0 for the 2 raised to the power 5 times L2 for the 2 plus n raised to the power 4 times L0 for the 2 raised to the power 4, okay, times L3 minus n raised to the power 5 times L0 for the 2 raised to the power 3 times L4 for the 2 plus n raised to the power 6 times L0 for the 2 raised to the power 2 times L5 for the 2 minus n raised to the power 5 times L0 for the 2 1 times L6 for the 2 plus n raised to the power 8 times L7. So this one, learners, I will use all the coefficients now from L0 up to L7 to get the value of L7. This is the last step, means after finishing this, you will get the new 8-degree room equation, and after that, also you are going through this 8-degree room equation, sorry, through this new 8-degree room equation, and you should solve it, okay? After that, go back to the original 8-degree room equation and make the cuts. These are the excerpts, and then you identify which of the 8 original degree room equation. I will take like this. So here we start from the beginning. A negative 7, I will write negative 7 times 16 raised to the power 8 times 16 raised to the power 8. Okay. Then plus, okay, 16 raised to the power 6 plus 16 raised to the power 6 times 7,132. Why we ignore 8 squared over 8 squared? It's going to be 1 learners. Okay, it's equal to you. Okay, I want not to write the coefficient of my original 8th degree polynomial equation as decimal numbers. Okay, I put like fraction. Okay, so minus 16 raised to the power 5 times times 225,920 plus plus is plus I didn't write it plus 16 raised to the power 4 times 4,449,726 minus 16 minus 16 raised to the power 3. Good man. Times 55,000, 55 million times 55 million, 799,680. Then plus learners, 16 squared. Okay. Times 435 million plus times we called صح 16 squared 256 times this one means I will make times. I will use my mouse. Okay, times 435 million 55,468 468. Okay, minus 16 times 1,928 million. Okay, 228,224 plus okay plus 3,719 plus 3,719 plus 3,719 million. Okay, 657, 657,000, 657,000, 657,000. After that, 865, 865. This one learners has to be equal to what? Has to be equal to 3,465. Now I finished the first step. We reached level 8. Now, learners, you are going to go to move, okay, not to take some rest, okay, but to move to the next level, which is B, okay? Not bye-bye, level B, not level bye-bye, okay? Okay. So, now I will make conclusion. So, this is S0 is going to be 0, S2 is going to be 0, S4 is going to be 0, S6 is going to be 0, else S1 is going to be negative 36, S3 is going to be 446, S5 is negative, okay, negative 2,196. Now I'm going, and S7 is 3465. I'm going to write this as that x. So our new nth degree polynomial equation that is obtained from the original 8th degree polynomial equation after using the discrete formula of me, we can be written as x raised to the power 6 minus s0 of order r x raised to the power 7 plus s1 of order r x raised to the power 6 minus s2 of order r x raised to the power 5 plus s3 of order r x raised to the power 4 minus s4 of order r x cubed plus s5 of order r x squared minus s6 of order r x plus s7 of order r equal what? Equal 0. So we told S0 is 0, S2 is 0, as this one. I mean, this one is gonna be 0. لا أمر ليس only purpose. Okay, no problem. This one is gonna be equal to 0. I will make like that if possible. Okay. And this one also, S2 is gonna be equal to 0. Only the coefficient learns, huh? Okay. Also, S4 is going to be equal to 0. So I'm going to rewrite again, but without S subscript even numbers. Okay, subscript even numbers. Minute, sorry. So this one, how can I write it? Okay, okay. I will take this. لا. Okay, copy. I'll come here. This is a 6. What is this? لا 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 ما لازم. why like that. Okay, اعمل هيك واعمل x raised to the power. هاي خلاص no need. I will write it again. So this one it will be like that. Okay, this is 5. Okay, I will change this by 5. 5. Okay, this is of course 2. Okay, plus this is minus, plus minus, minus. Then I will write this one as that. Okay, خلاص. That's it like that. So you see the coefficient S for this is S6, S6. Okay, we told that S6 equals 0, S4 equals 0, S2 equals 0, or S0 equals 0. I will write this again, but without the coefficient of 1k equal 2, 1k equal 3, 1k equal 5, and 1k equal 7. Okay, I will write this as s x q x raised to the power 8 plus s1 for the x raised to the power 6 plus s3 for the x raised to the power 4 plus s5 of all the x squared plus s7 for the equal 0. So you see, this is s1 of all the equal negative 36. That's why I'm going to write here negative 36. S2 learners, S3 is 446. So this is S3 like that. S2 is negative 2196. I will write negative. Okay, therefore, I will continue. This is minus, this is minus. Now, learners, if you are going to put x squared in this one, equal capital X. So we will obtain x raised to the power 4 minus 36 x cubed plus 446 x squared minus 2196 x raised to the power 1 plus 3 2,465 equals 0. This is now we obtain, in fact, we obtain new 8 degree from the equation, but we can let or substitute capital X with the square of X to reduce the power. Okay, it will be x4 minus 36x3 plus 446x squared minus 2,196x plus 3,465 equals 0. The roots of these learners are in fact 3 and 7, okay, 11 and 15. Okay, so x squared equal 3 means x equal plus negative root of 3 only. Then x squared equal 7. Therefore, small x equal plus negative root of 7. Then x squared equal 11. Therefore, x has to be equal to plus negative root of 11. Or x squared equal 15. Therefore, x equal plus negative 15. Okay, these are the roots of this of these. Okay, this the x roots of the new 8 degree polynomial equation. This one capital X equal 3 or 7 or 11 or 15 is the x roots of this polynomial equation. Okay, now okay, I'm going to continue. This is 15, this is 11, this is 3, 7, sorry, the roots. Okay, the x roots are immediately 24, 8, negative 8, and negative 24. Okay, the sum of S0 of order R, we call the sum of x's, which is x1 plus x2 plus x3 plus x4 equal 24 plus 8, 24 plus 8 minus 8 minus 24 is going to be equal to 0. Now we proceed, we continue, we will solve this and we'll show the really 3, U7, U11, U15 arguments. Let's continue. Okay. We calculated learners now S1. Okay. S1 is going to be, I will take this for you. So it will be easy for you learners because I'm going to use this new fourth degree from the equation that I obtained when putting x squared equal what? Equal a capital X. Okay. I'll put it here down because I will need this. Okay, this is no need now. I will erase all of this. Okay. Okay. I will make enter. Go back. This is the polynomial p of x equal, of course, Mr. Murad. P of x has to be equal to x raised to the power 4 capital X, of course. Okay. Equal x raised to the power 4 minus 36 x raised to the power 3 plus 446 x squared minus 2196 x raised to the power 1 plus 3265 equals 0. Now we calculate this. We obtain that S1 equal negative. Okay, I will calculate it. Okay, so I will suppose L0, I will use this one. Okay, I will write here again if it is possible. Okay, so all of this, okay, this one is going to be 0. S1 is going to be negative 640. Therefore, the roots of this polynomial to the power 4, or will obtain a new polynomial with highest power 4 that has to be written as p of x equal x raised to the power 4 plus s1 of order r x squared minus S2 of order R x plus S3 of order R. And S2 is going to be equal to 0. Well, S0 also here is going to be equal to 0. Therefore, I'm going to concentrate on S1 and S3. Okay? Therefore, this one has to be equal. Learners what? Equal, I will suppose this is S1 for the Q dash equal negative S1 for the Q, S1 squared plus 4 times S3. I should calculate this. You can write it negative, okay, negative negative 640 squared plus 4 times 36,864 equal negative 262,144. Therefore, this is negative. I'm going to put negative sign in front of the discount formula as one of all the two dash. I will obtain positive numbers. So this one is in the square of 512. Now x squared, because this is x raised to the power 4, okay, quadratic formula when putting small x equal x squared. So will be x squared equal negative this one, because this is negative. If it is positive, if it is positive, we'll make negative and so on. Negative s1 over the q, which is okay, plus learners root of negative s1 over the q divided by 2. So it will be 640. Okay, because this is negative number, negative 640, give it a negative number, will be 640 plus, okay, plus root of 512 squared. This one has to be equal 640 plus 512 divided by 2, which is equal to 578, which is equal to 24 squared. Therefore, x squared equal 24 squared. Therefore, x subscript 0, 1 is equal to plus negative 24. Now we go to the roots. I will make alpha subscript k 0, 1 is L0 for the q plus xk 0 to 1 over 4. It will be 36 because L0 is 36 plus negative 24 divided by 4. It will be learners a 3 because 36 minus 24 is 12. Divided by 4 is 2. Then 36 plus 24 is 60. Divide by 4 is 15. You see? Then we go to the next. When x equal, I will put the negative sign in front of the root of negative x1 of all the two dots because this is positive. Here has to be equal to negative. So x squared is equal to negative s1 of all the q plus negative, sorry, root of negative s1 of all the q dash divided by 2. It will be 640 minus root of 512 squared divided by 2 equals 640 minus 512 divided by 2 equal 64. So x squared equal x squared. Therefore, x subscript k from 0 to 1 is plus negative 8. Now, I will just substitute. L0 here is 36 now. I will just put this in 36. Plus 8 is, okay, we call it 36. Okay, plus 8. Okay, or minus 8. 36 minus 8 learners will be 28. Divide by 4 is 7. Okay. Then 36 uh, plus 8 is 44. Divide by 4 is 11. You see, the x roots are real. Therefore, if the x roots of our new 8-degree polynomial equation are real, okay, because we obtained from what? From the fourth degree polynomial equation when putting small x equal capital X. Therefore, I will continue learning. I will obtain, okay, this is, we repeat this. Okay, this is no need. I will just erase this one. No need. Okay. Now we told that this is 3. I will make it 3, of course, because real roots, simply because it is 7, 11, and this is 15. Okay. Look now. If x squared equals small x, capital X, equal 3 or 7. This is positive. For small x is we told is plus negative root of I. I plus I will raise the I, root of 7 plus negative. Or, of course, root of 11. And of course, root of 15. Of course, you should put the negative sign outside. Because if x square equal, okay, if x square equal to 3, small x, small x equal plus negative root of 3. If equal to 7, small x equal root of 7. Of course, plus negative. Now, I will go back to my 8th degree polynomial equation, 8 to my 8th degree or my origin 8th degree polynomial equation that I will start with. I will make L0 which is 16 plus yk which is yk. I will use plus negative root of 3 or plus negative root of 7 or plus negative root of 11 or plus negative root of 15. Okay, I'll just raise this I, meaning all the roots are real numbers. Okay, so these are the roots of my 8-degree polynomial equation. Clear learners? If you want to check, you see, concentrate on this. I'll put here if you want. Okay, okay, complete. Okay, let's check this one, learners. We'll have what? 16, okay, 16 squared plus a 3. Open parentheses, make 16 squared plus 3. What is parentheses? Okay, 16 squared plus 3 plus 3. Why? This simply because I will multiply 16 squared minus 3, 16 minus 3 times 16 plus, sorry, 16 minus root of 3 plus times 16 plus root of 3. This is the difference between two squares. Ignore the 8. The 8 after that will be 8 raised to the power 8, okay? Will appear in the last coefficient of my original of my original 8 degree from equation. I'll just focus on the numerators. It will be this one 16 squared minus 3 will be 259 times open parenthesis 16 squared of course minus 7 close the parenthesis simply because 16 squared minus 7. Why? Because the difference between two squares when you multiply these two real numbers. When you multiply these two roots of my original 8 degree from the equation. Times what, learners? Okay, times open parenthesis, Mr. Murad, will be 16 squared, means 16 squared, right? There is no change, so that all the learner, professor, and colleagues can see, minus 11, close the parenthesis, times, times what, learner? Times 16 squared minus 15, open parenthesis, times 16 squared minus 15. This one has to be equal, in fact, what? Minus 15. Close the parentheses. So this one has to be equal to what, learners? I didn't make equal sign, I will do it after. Okay. This one has to be equal to the last coefficient of my original polynomial. Okay. This is the last one, so I'll make, okay, like that. Go here and make what so that everyone can see. Okay. We told ignore what? Ignore learners the eighth raised to the power 8. Why? Simply because I will multiply just the numerators. The denominator, it's clear that 8 solution, 8 roots. So 8 multiplied by 8, 8 times means 8 raised to the power 8 is written here. Therefore, I'm going to make right equal sign. You see this one? I'll do it again. 8, okay, and 7. Okay. I will use also my calculator. Okay, I enter the calculator. This is my pen. I'll give you 5 minutes to think. Okay, we have 256 minus 3, 253. Okay, minus 7, 249, then minus 11, 245, and then minus 15. 241. Okay, minus 245, minus 249, minus 252. Yes, you see? This one, you see, I don't know if you see it or not. I don't know. Okay, means here the artificial intelligence interfere. Okay, I will make now like this and I will go like that. Look at me. We have 240. Okay, we have 253. Okay, 253. Okay, times 253 is 16 squared minus 2 times 16 squared minus 7, it will be 249 times 249. Then 16 squared minus 11, it will be 245 times 12 the last one, 245. And 16 squared minus 15, it will be then 241. This is okay. You see this one? The last coefficient is, I mean this one. The numerator 568, 568, 756, 756, 9173, 9173. Okay? Okay, so I'll repeat this again. We told is 16 squared, 256 minus 3. Close the parentheses. Open parentheses. It will be 256 minus 7. Close the parentheses. Times open parentheses, 256 minus 11, close the parentheses, open parentheses, times 256 minus 15, close the parentheses. Okay? So these, because the roots we told 16 minus plus root of 2, or divide by 8, of course. Okay, we told now I'm going to ignore the 8 because it's clear. The numerator value will be appear. The 8 raised to the power 8 have been, has been appeared. Okay, now just I'm going to focus on the numerators. So this one has to be equal to, now without AI, because sometimes okay. 3719, okay, 657, okay, so these we called it's a polynomial to the power 8 and has 8 roots. This is according to Mr. Murad Sultan Ezouidi. Okay, I wish that you got the point. Okay, Safedin. Hello, Safedin, how are you doing? Thank you, my best friend. Thank you. My sister Nadia, usually are fine. Now I finished, let's say, explaining how can you solve polynomial to the power 8, and thanks to God and thanks to my colleagues, those who are interested for knowing new method of Mr. Murad Sultan Ezouidi, how can we solve polynomial to the power 8. And this had been done for for your sake, learners, colleagues and professors. Okay, and those who are doing researches, it's now time to come, okay, and work with my own formula. In fact, let's say it's a booklet of mathematics like that. My son, my kids, okay, this is edition universities. You see, go, Mr. Murad, okay. These are my projects. All of these, my books in mathematics. All of this. You see, okay. You see this one? Putting to the power 4. Putting to the power, this is nth degree equation. This book is very important, contains all the theories, okay, of Mr. Murad Sultan Ezouidi. Okay, this one I mean. So this is my books of mathematics. It's written in French, okay, and of course Muhammad Radawi, my best teacher in mathematics, is the one who taught me when I was a student. I love him so much, Muhammad Radawi. It's a message I'm addressing now to Mr. Muhammad Radawi. I'm addressing to Mr. Muhammad Radawi, the best mathematical teacher. That I loved him so much because he believed he believed in me, and he believed in my skills in mathematics. And one day he told to my eldest brother, "Hey there, take care of your brother. He is very smart, very intelligent. Give him power. Give him power. Don't let him give up. Okay? Encourage him and enthusiasm him. He is very smart. One day you will see my opinion." And thank you for that, Mr. Muhammad Al because you are very curious and you got right opinion of your student Murad Sultan Ezouidi. And this is your name, Mr. Muhammad Al Okay, so now if you are going to show you something here, this of course for author use only. This is my own book. No one can steal my theories. Okay, everything uh, is published under my name and the name of my teacher Muhammad Radawi. Edition Universities of European. Okay, European University Edition. So, of course, here you see copyright Murad Sultan Ezouidi and Muhammad Radawi. Copyright 2021 Dodo Books Indian Ocean. LTD member of the um, Omniscriptum SRL Publishing Group. Okay, means that I am very happy to share this kind of work for you learners, professors, and students. Okay, you see, one theorem depends for me more than 30 pages. You see, 30 pages, and very, very extraordinary, really, this kind of equation. Okay, thank you for listening, and see you. Sorry, next time. Okay, I will tell this one. Okay, so many books, in fact. Okay, so all these books had been written in English, in French. I changed it in English. Okay, and I hope so that my books will see light one day. This is going to the power 12, this is going to the power 8, and so on. Okay, so of course we see theories theory the resolution of polynomial معناها in English uh, theories for solving polynomial, or it says theories, yes, theories for, or theorems for finding out the roots of any integer communication. Thank you for listening. This is Murad Sultan Ezouidi, the pioneers in methods. Of course, volume to the power 16, we solved this. Volume to the power 14, it's a book. Okay, and what else? This is volume to the power 6, solved by Mr. Murad Sultan Ezouidi. Okay, so we close the parentheses. Thank you for watching, and I wish that everyone is gonna be heard about the channel of another call. Another call means not it means let's not mean I will take my mobile and make a call. No, I have a target. Okay, I'm going to take another phone for smart minds. Okay, for smart minds, for those who are interested in mathematics, to get and start working with new theorems, with new methods that you didn't see before. Never in America or in Australia or in Canada or in Egypt or in Tunisia or in Saudi Arabia or in UAE or in Jordan or in Yemen or in Iraq or in Iran or in Russia or whatsoever the country that you are now watching, you didn't see this before. Okay, but now you can see and you can work with it, because I am the one who discovered this, and I published my own books regarding to this kind of theorems of Mr. Murad Ezouidi, and I'm able to solve any problem to the power n whatsoever the coefficient that we will get from the new from the original nth degree polynomial equation. There are so many levels in this kind, and nothing will be impossible to figure out the exact value, okay, of the roots, of course, of this nth degree polynomial equation. And it's time to think again, okay? This is Murad Sultan Ezouidi is addressing to you, to everyone who has smart minds, to everyone who love mathematical subject, who everyone who does really believe in himself and does believe that, yeah, we can, as a human being, solve, let's say, difficult problems, okay, using new methods, new methods, new pathways that will lead you to the sea of science, sea of knowledge. Okay, you see the sea of water, the sea of water, the sea. You see the sea, the waves, the sea, the waves, the waves, the sea. You see, it doesn't like. You see, I mean, you see the sea. Okay, you see the sea. You see the waves. You see like that? Good man. You see like that? Excellent. You see like that? Very good. So you see like that? Yes. One day we'll go and God will finish our life. This is a fact. And we'll take with us nothing, just your work, okay? And charity. Nothing. Don't tell that I got money or you got cars or you got houses or you got garden or let's say area, let's say large area. No, this is nothing in front of science and knowledge. Okay, is nothing. And Quran is the main important thing. Okay, is the whole thing that I'm diving in. Okay, and thanks to Quran, I got this kind of theories. I swear to you, let's say thanks to Allah and to the Quran that He gave to our Prophet Muhammad, we got this kind of facts, this kind of theorems. Okay, and the more I read Quran, I read verses. Okay, I read, let's say, uh, uh, Quran. I let's say like you were in a comfortable situation, you reach to comfortable situation in thinking, not in ability or standability or instability. No, in thinking. When you think and the line that you are uh, working on is like waves, meaning that be careful. Maybe we'll let's say we'll fall in gaps. Okay, means may you will jump, but uh, make sure that there is no gaps in front of you. But when you are on the same level of uh, of of accuracy, degree of accuracy, sorry. So it means that you like to make full turn, okay, full turn around the point, but this around is gonna be giving you the power and the uh, the power of its Murad and goodbye. Love you so much. Yalla salam. I'm going to stop this. Thank you for listening. This is Murad Sultan really the pioneers and methods. Okay, with you, I'm going to stop this. Okay. So we told that thank you for listening. Thank you for listening. This is Murad Sultan is really the pioneers and methods. Okay. He loves you so much and he will never hesitate to give you what is possible. Okay, what is possible is gonna be now on your hands. Okay, and think that one day you will go and you will leave us, but you will take with you nothing. Just your work will be, uh, how to say, it, will be memorized or kept in such an area, in such an area in such area, sorry, in such area of intelligence, of knowledge, of charity. Thank you and goodbye. This is Mr. Martin from Ezouidi. Okay, we wish that my own wish now is to let my researches in mathematics spread out. Okay, and I'm addressing to everyone who believe in himself and he never hesitate to give what is possible. Give what is possible. Okay, because in the sake for this humanity, human, for your sake, let's say, for your sake, okay, we are uh, involving to let you learn from new methods of Mr. Murad Sultan Ezouidi. Okay, thank you and goodbye. One time we will also involved into the power 9 and 10 and 11 and 12 and 13 and 14 and 15 and 16. 16. What again, Mr. Murad? 16. Okay, thank you and goodbye. Goodbye. Bye bye.